Hi, my name is Rialda Spahic. The title of my PhD is Risk-Informed Artificial Intelligence for Autonomous Pipeline Inspection on Subsea Pipelines. My PhD was a part of BRU21, Program Area New Business and Operational Models, and was funded and supported by Equinor. So far, we have experienced the opportunities in remotely operated vehicles for manually inspecting the pipelines and looking for hazards. But more recently, we see an increase in potential of autonomous systems that can reside under the sea and perform pipeline inspections and interventions if and when needed. These systems rely on artificial intelligence to be able to perform these tasks as autonomously or independently as possible. And the artificial intelligence approaches depend on the collected data, such as the image data, to learn from and recognize patterns surrounding the pipelines. There are two basic ways that the AI systems can learn. First approach is when we have a set of training data from which the AI systems can learn the patterns to detect objects, and this is called supervised learning. But creating the training data for this type of learning requires manually annotating thousands of images, which is time-consuming and tedious. Second, the more common approach is the unsupervised learning, where the AI model recognizes objects on its own by observing their shape, color, texture, and other properties. But there often isn't enough evidence in the data of the hazards on the pipeline that we are looking for so that the AI can learn their patterns and detect them, which results in missing out on important information such as hazards on the pipelines. And it creates the challenge of training AI to extract the valuable information from these massive amounts of data that has very little evidence of hazards that we want the AI to learn about. This leads to the proposed solution, the Warning Identification Framework, which forms two components, the AI component with anomaly detection and the supervisory component from domain expert knowledge. We use the sensor-collected data on seismic tremors and from domain experts-derived hazard analysis to tell us about the properties of hazards, their occurrence, and the consequence or the severity of their impact, so that we can supervise AI in efficiently detecting the hazards from a massive amount of sensor data and minimize the occurrence of noise. Another proposed solution tackles the lack of evidence of hazards in image data to train the AI in detecting the pipeline damage. In this case study, we have obtained over 200,000 images of pipelines by an underwater autonomous vehicle and propose a low-cost methodology that addresses the lack of training data with pipeline damage by creating synthetic damage on real images and improving the performance of anomaly detection methods. This is done by applying a guided image interpolation method for seamless blending to a real image called source image that contains the anomaly or the damage. We mask the damage from this image and interpolate this mask to another real image without any anomalies called the destination image. This results in image D, the seamless blending of a real image from one image to another. Here are some more examples of resulting images after seamless interpolation. The beautiful part of this approach is that we can manipulate the masked anomaly or the damage, change its size or shape, and create batches of images with synthetic damage. Now, the important part is to make sure that our models detect the damage and not other areas of an image during the classification task. And to ensure this, we use localized mechanical damage approach that extracts and highlights the distinctive regions of an image that were selected during the classification process. Creating synthetic hazard training data with low cost not only improves the training process of our AI system, but also provides an opportunity for sharing the synthetic data instead of sensitive information. The localization of anomalies reduces the resource waste by minimizing the noise, and knowledge exchange through supervision of AI models increases the reliability of the autonomous systems. Because the reliability of autonomous systems and the safety of remote operations cannot be overemphasized.